they're taking off as much. Oh, here, so on the recording, I'll flash the answer to number 2 there. That's number 2. This is number 3. Let's see. Number 4, convert 11320 from base 4 to hex. Most of the class actually did all right on this one. Okay, 11320. So this is a number that's currently in base 4. We want to convert this into base 16. So we're going to convert it to decimal first using our first pattern, then convert it to hex using our second pattern. So this is the ones place, the fours place, the 16s place, the 64s place, the 256 place. All right, so we have a 2 in the 4s place, so that's an 8. 2 times 4 is 8. We have a 3 in the 16s place, so that's a 48. 3 times 16. We have a 1 in the 128th place, so that's 128. And we have a 1 in the 256 place, so that's 256. So that gives me 440 in decimal, right? All right, so now I need to convert that decimal to base 16. So we do that by dividing by 16, recording the remainder. So 440 divided by 16 is 27. 27 times 16 is 432, so that's a remainder of 8. 27 divided by 16 is 1, with a remainder of 7, right? 16 times 1, so that's 4. Oh, am I doing that wrong? -7 minus 16. It's 11. Oh, I think some of you got away with points on this one then. And then let's see. Is that first part right? 440 divided by 16 is 27. 27 times 16 is 432, so that's remainder 8. That's right. Okay. So then we have 1 divided by 16 is 0. So we have remainder 1. So this should be 1B8. Should be what the right answer is. I think I gave credit for a lot of other answers. Did I not? I think a lot of people got credit for a different answer. This 440 is correct, isn't it?
No, well, isn't it 4 to the 3rd power?
Here, let me redo that first part. So this is the ones place. This is the fours place. That should give me a 4 times 2 is an 8. This is the times 4, which is the 16s place. So this is 4 to the 0, 4 to the 1, 4 to the 2.
And 4 to the 3 is 64. Yeah. Not 128.
Oh, thank you. All right, so it's...
Yeah, it'll give you 376.
Yeah. And then this is 256. So this is 376?
Yeah.
All right, then our math is going to be different here. 376 divided by 18. 376 divided by 18 is a 20. Oh, what'd I do? Oh, thank you. That's a 23. See, this is why you show your work. 23 times 16 is 368. So that happens to be an 8 for your last digit anyways, right? Then we have 23 divided by 16 is 1. 1 times 16 is 16, and that's a remainder of 7. Then we have 1, so the final answer is 178. That should be the right answer. Yeah, so this is the ones place, the fours place, the 16's place, so 16 times 3 is 48. Then this is the 16 times 4's place, which is the 64s. And then this is 64 times 4, which is the 256 place. So that's 178 for that one. So you just had to go from base 4 to decimal, then from decimal to base 16, and probably should have written down your powers instead of trying to do it in your head like I did. Okay, so write the necessary C code, number 5, to display all of the prime numbers between 1 and 100,000 to the screen. All right, and I told you what a prime was. Now, a reasonable person maybe would have gone ahead and written a little function to determine if something was prime. So, maybe have, in C it would return an int, but if you said bool, that's fine. Maybe call this guy is prime. This guy takes an int n as a parameter, and this guy should return true if n is prime, which means it's only evenly divisible by itself and 1. So, there are some tricks to cut down the number of things you have to check, but to check primes is actually a fairly complicated thing. So the most straightforward for an exam way of doing this would be just loop through all the numbers between 2 and n minus 1. All right, so we'll say int I for I is equal to 2, I is less than n, I plus plus, if n mod I is equal to 0, that means we have found something else that evenly divides n, other than 1 and itself. So we'll return a 0. If we survive through this, we'll return a 1.
Why not just do time divided by 2?
You could do that. There's all sorts of ways you could shortcut it. Okay, but if you're not trying to come up with some math trick in the middle of an exam, check all the numbers between 2 and n minus 1, and you got your thing. Because you could make another argument for working with the square root of the number. So I think it's a square root plus 1 actually cuts it down even more. So pick your poison. I know some people tried to do mod 3, mod 5, mod 7. I think there's some number in there that you find that will actually be evenly divisible by one of them that's actually not prime. You kind of have to play a game farther out than that. Prime numbers is the basis for a lot of our encryption algorithms, because detecting very large primes is actually quite complex. So there's actually algorithms out there for determining whether a really, really, really big number is probably prime. That's the what the algorithm is for. Not that it's definitely prime, just that it's a very high likelihood that it's probably prime, but we can't calculate it for sure. Something like that. But any sort of algorithm that you wrote that roughly determined whether something was prime, you got most of the points. All right, so now we're going to use this guy in the other part. So now we're going through what? All the numbers between 1 and 100,000. And printing out which ones are prime. Okay, so int I for I is equal to, did I say 1 or did I say 0? What number am I on? All right, 1 and 100,000. So for I is equal to 1, I is less than or equal to 100,000, I plus plus. All right, so that's actually fine on the screen. So now we're going to ask the question, if is prime of I. This will work as is because in C, Booleans are represented as 0s and 1s, but if you wanted to make yourself feel better, you can say is that if it's equal to a 1, that must mean it's a prime number, therefore spit it out. But if that guy is prime, we'll do a printf %d / whatever. You didn't have to backslash it or anything. And we'll print out I because that's a prime number. So that'll print out the numbers between 1 and 100,000 inclusive that are prime. Make sense? That's the prime guy. Let's see. 6. Write a C function that takes a string as a parameter and returns that string with all the numbers removed. Most people made this way more difficult than it needed to be. All right. This required you to, in order to do this simply, it required you to consider Unicode, or probably ASCII if we're dealing with an older C compiler, by writing a function or just the code. Write a C function that takes a string as a parameter. Okay. So we're going to have a C function, and this guy's going to return a string. So this guy's going to return a char pointer. It's going to be called remove numbers, remove digits, whatever you want to. It's going to take a char pointer s as a parameter. All right. And we probably also want to take in the length of that string. I know technically size of will work on strings and things like that, or you can count. But if you know the length of your string, you can just use that as your count. You didn't lose points if you didn't do this. It was fine. All right, so I know the biggest that my answer is going to be size length, which is the length of s. So I'm going to go ahead and create my answer. So I'm going to create a char pointer answer, and this guy is going to be equal to malloc of length times size of char. Technically, size of char is a 1, so if you left that part off, you didn't lose points. Okay, so now we have a place to put our answer. We want to go through every single bucket of S and consider the character we're currently looking at, because we want to know if it's a number, we want to skip it, right? If it's not a number, we want to keep it. So let's write the loop that goes through every number, or every character rather, in S. So we'll say int I, then for I is equal to 0, I is less than length, I plus plus. So this will spin through every single bucket in S. Now I want to be able to ask the question, is that guy a number? So I can say if. Now the way I get this specific character right now is I want the value that lives at S plus I, right? That's my offset. That'll give me the current character we're looking at, right? All right, so I want to know if that guy is less than 0, or that same guy is greater than or equal to 9. If it's before the digit 0 on the Unicode or the ASCII chart, it's not a number. If it's greater than 9 on the ASCII chart, it's not a number. If either of those things are true, we want to keep it. Correct? I want to keep it in my string.
Why do you have it if it equals 9?
Oh, I want to just be greater than 9. It's greater than 9. So if it's outside the range of the Unicode or the ASCII values, they'll be the same values. If it's outside of that range, I'm going to keep it. Now, I'm going to put it in my answer, but I need to know where to put it. I can't necessarily rely on I here for where to put it, because I might be jumping, right? So I'm going to need to keep track of maybe, well, we just call it pause. Start pause off at 0, and we'll go ahead and say the value that lives at answer plus pause is equal to the value that lives at S plus I, and then make sure you increment pause to move on to the next one. If it is one of these numbers, we're just going to skip it. Keep moving on. Remember that when you create a char pointer, it fills it up with \zeros anyways. So the worst that happens, you return a string that has a little bit more memory than it needs, but it still is filled up with everything that is not a number. Now, what some people did, and I gave you credit for it, is what you did is you built up a string and you replaced the numbers with like the an empty character or something like that, kind of showing you identified a number or you identified something that looked number-esque. You know, some of you did the giant if statement that if I'm looking at a 0 or I'm looking at a 1 or I'm looking at a 2 or blah, 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 that kind of stuff. So some sort of logic that matched whether or not you were looking at a number was reasonable, but this is leveraging your knowledge of that mapping between ASCII and Unicode. And if you didn't like comparing chars directly like this, you could have also converted these to ints, and then you would have felt more comfortable that you were comparing the Unicode values of those guys directly. All right, that one makes sense? All right, so let's remove numbers. That was which number?
6.
All right, number 7, write a function that takes 2 integers and returns the largest integer that evenly divides both integers. Okay, so we're going to be returning an int. We're going to call this greatest common divisor. We're going to take 2 integers, so int A, int B. All right, you can go ahead and determine which of those 2 is largest if you want. That would save yourself just a little bit of time. Or you can just decide to start with 1. And the worst that happens, you'll be wasting several iterations through your loop, not being able to, like a 7 would never be evenly divisible by a 14. Something like that, but you could still check it. It's not going to hurt you to check it. But common approach to this would be determine which value is larger. So we'd say int max, maybe start off at A, then ask the question if B is greater than A, then set max equal to B. So we know after we get through that little place there, max holds the larger of our 2 values. We actually want the smaller of our 2 values, right? So min is A if B is less than that, set min to B. So now I have the smaller of my 2 values, which is the largest value that might evenly divide both of them. Okay? So now I'm going to whittle down from min all the way down to 1. We know 1 will evenly divide both of them, right? So we'll say while min is greater than 0, if A mod min is equal to 0 and B mod min is equal to 0, if both of those things are true, we'll go ahead and return min. Otherwise, min minus minus. We're still kicking down here. We finished checking everything. We were dealing with 2 prime numbers. Well, not necessarily, but we could just say return 1, or you can return min, which currently is 1. So this while loop will go from the smallest of our 2 numbers down to and including, actually this will already, we know this will actually finish. And in C, we wouldn't have actually had to return. C would not require you to have a return statement. You know how Java complains? So you could have actually omitted this, just knowing that you will eventually hit return min here. But from a Java programmer's perspective, they would have probably thrown this catch-all of a return 1 out there. All right, so that is greatest common divisor. Question on that one. What number are we on? 8 now? Oh, this is the merge one. This was the controversial question. I said you could assume they're the exact same length, didn't I? People. All right, so merge strings. And I'm returning a new string. So char pointer, merge strings. This will take a char pointer S1, char pointer S2, and maybe an int length. We know our answer is going to be length times 2. Double the length of these. We're merging them together. We're going to end up with all the characters going to be in there just kind of interswitched. So we'll say char pointer answer is equal to malloc of length times 2 times size of char. So that'll give us enough memory. Now, we know that we're going to be placing stuff at position. We're going to need a couple of different counters. We need to keep track of where we are in our 2 strings, S1 and S2. Okay? then we need to know where we are inside of answer. So I can go ahead and say maybe int pause is equal to 0. Maybe this keeps track of where we are in S1 and S2. And you could have thrown these inside of a for loop if you wanted to take advantage of the, the for loop little cheat thing, but, whatever. So int pause is equal to 0. Then we need to keep track of where we are inside of answer. So maybe we'll say int I. Then we'll say for I is equal to 0. I is less than length times 2. I plus plus. So this is going to take us through all the buckets of answer. Each time through, we want to store in answer the character at bucket pause in S1 and the character at bucket pause in S2, and then increment pause. Right? And we're going to store this in answer at bucket I and bucket I plus 1. So we actually want to say I plus equals 2 here. We're going to take jumps of 2 because each time through this loop, we're going to be filling in 2 characters. So we'll say answer, or the value at answer plus I is equal to S1, the value at S1 plus pause, then the value at answer plus I plus 1 is equal to the value S2 plus pause. Then we'll say pause plus plus. That'll knock us to the next element in S1 and S2, which we know are the exact same length, right? That was given information. All right, so that moves us there. I will become 2 greater than it was next time. And we put in bucket I, and we put in bucket I plus 1 in answer. In the end, the answer should be filled up, return answer. Like that. So that should merge our strings together. Oh, and then the last one was so much fun. I'm kind of disappointed that not everybody got to that one. If I take a minute and look at number 10, if you didn't get to it, look at number 10 and see if you can figure out what that one does. And then I'll tell you what it does. I didn't do 9? Oh, well, that's because 9, I shouldn't have to do 9. I also shouldn't have to fix your front slash, Corey. Who else's front slash did I fix? I fixed somebody else's front slash. Yeah.
I got the right symbol, just orientation. So.
No, that's a different key on the keyboard.
Yeah. Why did you think of that?
You got the mirror image. Like, look, you didn't say I couldn't make it look like it was in a mirror. So I fixed it and took off 90 points.
Got -1,000 for one of the exams once.
I know. Did you deserve it?
I think what happened was
I should have taken off 1,000. Brennan's exam.
I wrote the wrong answer, realized it was the wrong answer, scribbled it out, wrote a note that I wrote it at the end of the test.
Oh, yeah.
Oh, so I gave you a preemptive minus 1,000.
Yeah. The answer was right.
I had a teacher in college once. He was actually one of my favorite teachers. Pretty hard, probably a fairly similar teacher to me. Kind of has maybe more technical questions on tests and things like that. And I always did pretty well on his tests. I've always been pretty good at that kind of stuff. But I was kind of a perfectionist as a student. I never wanted to work with other students because I wasn't going to accept their crummy work, right? Okay. We were in a group, look, you just stay over there, you shut up, you do nothing. You get my grade, I'm not touching your grade. That kind of. So he hands back my test. And I mean, I knew I aced this test. So he hands it back and it puts like a 41% at the top of it. Okay. And I like immediately flip out. just so I mean, I'm like looking at the test like where did I miss points? I'm not seeing anything. And on the back, he like wrote this little, sarcastic thing it is. It was pretty funny in the end. Because this was like a really upper division class. It was just me and like 3 or 4 other students that would take like this specific class. And we were all like buddies. They were the people I would have trusted in a group. So they were probably all in on this. It was pretty funny. All right, so what was the number 9? Okay. Everyone should have gotten number 9 right. That's the string termination character. \0. Okay. Finally, number 10. Anybody, does anybody who just looked at number 10 want to take a stab at what it does? Some of you had already done it. You might have gotten points on the test or something like that. This was really testing, did you understand how fork worked? And in fairness, if you were on a very, very, very old and slow computer, or you gave it a sufficiently large value for A, you possibly would have gotten a slightly different output than this. Okay? But just slightly different. So for example, if you gave it an A of 5, you would get chugga, 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 choo, choo. Right? His parrot is going to wait for 1 second while the children are each printing out chugga. That's what the choo-choo trains make, the chugga, chugga. Right, Brennan? Yeah.
How many chuggers was it? 5?
Well, it was A chuggas.
8?
A, whatever A was. So A gets passed into woot, right? So there's A chuggas, however, whatever value you pass in for A initially. Now, what's interesting about this is we're doing forks, but we're making recursive calls back, right? So this would probably get a little bit hit and touch and go if we had a really large value for A, because then you're starting to run out of memory. But we're recursively calling it back, and it's the children are going to keep saying chugga, 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 chugga while the parents just sitting there waiting. And choo choo.
If you write this in AWS past like 800,
100 wouldn't.
The child will
okay, fine.
Like a billion might.
Okay.
All right. So that should be all the questions. Questions, comments, concerns, bribes. I feel I was pretty fair in the curbing.
Have you ever had an exam take everybody that long before?
No, I'm usually used to having smarter people. I don't know. Sometimes you write an exam, and when you think about it yourself, there's certain questions that the way you would do it wouldn't take as much time. Like for instance, the Unicode thing, where somebody else, you might have spent 5 minutes writing this monster and/or thing or something. I didn't consider that, so it happens. So, all the teacher can do is either curve it at the end, or I just kind of said everybody in the class finished at least 7 questions. So I'm just going to pick everybody's best 7. Grades were higher than they should have been in the end, but I'd rather err on that side than have a bunch of people slashing my tires. All right. Any questions? All right, so we'll come back on Wednesday. We'll keep looking at our, start looking more at interprocess communication stuff. Remember, this week's Holy Week, so after any class that's after 4 p.m. on Thursday does not meet this week. And next week, classes that meet before 4 p.m. on Monday do not meet. Is that correct? I think I have that right. I think Monday's off. Is that Monday Monday? It's got a name. There's a name for it.
This Monday?
This Monday. So if your any class that's before 4 p.m. does not meet. So you should make sure you go to church on Thursday night and Friday night and Saturday. Saturday night's the one where they slam the door, right? That's a very yeah. That's the one where they're supposed to close. That's Friday night. No, it's Friday the slam the door one. That's when they the closing the tomb. Yeah, they slam the door. It's all scary because it's dark in there. They turn off all the lights.
I go to.
And then Sunday, then you have Easter brunch. So you go to church and work up a nice appetite. You're all excited, and then you just go eat just a ton of food. So good.
I'm here for the 7:30 service at the Bluff.
7:30 a.m. All right. Well, I'm not gonna make that one.
For senior